find the composition f of g of x for the following functions. And we're given f of x is equal to the square root of x plus 2, and g of x is equal to 8x minus 6. So let's start here by recalling that the composition f of g of x asks us to substitute the function g of x into the outside function f. And so we can even rewrite this as f of g. So it's a little bit less overwhelming with all the variables. And writing it in this notation f of g looks familiar. If we look up here at our function f of x, we see that f is defined in terms of one variable. So we could say that since f of x is equal to the square root of x plus 2, then replacing each one of these x's with g, we can see that f of g is equal to the square root of g plus 2. So now we want to go ahead and substitute our function g back in. So we are going to replace the g with 8x minus 6. So this will become the square root of 8x minus 6 plus 2. And I use parentheses here for safety. Since there's no constants or negatives on the outside, I can drop them, leaving me with the square root of 8x minus 6 plus 2. And we recognize that 6 and 2 are like terms, and we can rewrite this as 8x minus 4. And simplifying an extra step further here, we see that we have a greatest common factor of 4. Right? 8 is 4 times 2, and 4 is 4 times 1. So we can further simplify this answer here by factoring out 4. So I have the square root of 4 times 2x minus 1. And by the properties of radicals, we can rewrite this as the product of two square roots, the square root of 4 multiplied by the square root of 2x minus 1. And since 4 is a perfect square, we recall that the square root of 4 is the same thing as the square root of 2 squared. So the square and the square root cancel each other out to 2. So we are left here with a beautiful final answer, 2 times the square root of 2x minus 1. And that is the composition of functions f of g of x.